Made a file, made a geo, empty geo, go inside, delete the file, tab Tommy. That's our reference. Next, tab, geo again. I'm going to name this terrain. Go inside. You can also go inside by pressing enter, in addition to I. And this time, delete the file, tab, grid. And feel free to use the shelf tools, you know, I use tab. That's just the way I'm used to it. But you can also say control click grid there to get at your grid. So I've got my grid. Size. We don't want 10 and 10. I want 22 by 22. I want rows and columns. This is my resolution. 200, tab to get to the other one, by 200, enter, space G. And now you see where he lives. Okay, so let's put a mountain under him. Tab, mountain. Okay, so let's put a mountain under him. Tab, mountain. The height. We'll do like 4.6. Element size. Now, I like to make my own mountain in VOPs because I like traditional noise lingo. Frequency is what I like, but this is called element size. But it is nice that it's only one slider. That is nice. But element size and frequency are the same thing. In noise, with noise is very important in Houdini. You use it everywhere. And the more layers of noise, the better and more natural the effect is going to be. Look around you when you walk around the world. I mean, when you walk around in your life, like there's noise in everything, everywhere. Even on the floor right here, you'd make a shader. You can make a procedural shader that looks like this floor. It's noises on noises on noises. Everything is noise. So I'm gonna do Perlin noise. Let's see, what else do I have here? He's kind of floating in space a little bit, but that's okay. It's only a little bit, and he's only there for reference. I still think element size needs to be a little larger. Maybe I'll take the height down a little bit. Yeah, it looks a little better. Yeah, something like that. Cool. Gotta get him on the ground. I know how you feel. You good? You good? Everyone's got it. Excellent. Excellent. See, by the end of the day, you guys get fast. You're learning like so quickly. You guys are pros now. Look at that. Okay, good. Okay, time to make. We're gonna spend some time making our emitter. Cool. Okay, let's put these two objects aside. It's like a cooking show, like put your ingredients to the side. Tab, Geo. Calling this guy Snow. Delete the file. Tab, Circle. Okay. And again, radius. First of all, XY plane, we don't want that. We want the ZX plane. Let's lift it up, lift up the Y center 10. So now it's like a UFO that's gonna beam him up. Yeah. Radius 22 by 22. Let's make it a polygon instead of primitive. Yeah, it's really gonna beam him up. Okay, so this is gonna be our emitter. So under the circle, I want a remesh. A remesh is going to give me a lot more topology. That's going to be good. It's a little too high res. I want you to, in your remesh, go to adaptive. And we're going to take this value down, down, down. Take the density up. What adaptive does, if you see, it puts more resolution on the corners. It puts more resolution where you need it. It's pretty cool. Something like that. Something like that is good. Oh, and by the way, I turned lights off with this little guy right here. But you don't need to do that. But if you ever wanted to, that's right there. Okay. So before you even get into making particles, if you've got a good emitter, you're like so much of the way there already. We're going to make a really good emitter right now. We're going to do that by noising up. We're going to make, remember, we already did this. Like when we just made our forest, we put a density attribute on our scatter so that some parts had more density than others. We're going to do the exact same thing right now. We're going to make some noise, and through that noise, we're going to give more density to certain areas so that things are not homogeneous. They're not like, not this disk. The last thing we want is just like rain to come down or snow to come down like from every point equally, right? We want patches. We want patches of snow. I mean, think about it. Clouds are patches, right? It's not like one blanket. Sometimes it's a blanket. But even with the blanket, you're probably going to have some differences in density. Okay. We need a VOP. Point VOP. Point VOP. Okay. We need some noise. Let's do... There's so many noise. There's so many cool noises. It's hard. Like, but let's do anti-alias flow noise. Anti-alias flow noise. And I'm going to go P to position, P to P. And what does that mean? Remember, what is P? What is happening in a VOP? A VOP is, yeah, but it's altering, it's not necessarily, I mean, it's altering points. I mean, this case, we're altering attributes. We could alter points, but in this case, we're altering attributes. We're manipulating, we're creating attributes. But it's running over simultaneously each and every point. Simultaneously. That's what a VOP does. That's why it's so fast, because it's multi-threaded. Somehow the computer separates all this stuff up. But simultaneously, P, what does P mean? P is every single point simultaneously. When you put P in here, it's just putting into a noise function, you know, and it's very similar to what we did with the random function. The random function, we fed in each point number. We've got a noise function right here, and we're feeding in each and every point. It's very, very similar. And what do we get in the output? We get a range of numbers. Okay, so let's visualize this. Now, in my noise, I've got all these parameters: amplitude, roughness, flow, blah, blah, blah. Frequency, which I like. I want to promote all of these parameters to the very top level. So I'm going to say middle click, Vex VOP options, create input parameters. Go up, and they all get grayed out here. If you go up, now in my VOP, you see all my noise parameters have been promoted to this top level. That means I don't have to go into my VOP anymore. I don't have to go in there, but I have to finish it, so I got to go back in. So let's put our noise into the color attribute. So noise goes into CD, and now I can see my noise. Now let's go back up, and what do I want to do? I want to lower my frequency like so. I'm like pressing my wake up on my laptop screen. Yeah, something like that, like 0.15. Oh, I got something to show you guys. This is a fundamental. So I always want my X, my Y, and my Z to be connected to each other. I'm just going to do it this way because this is the global way. Selecting it, right click, copy parameter, right click on Y, paste relative reference, paste relative reference. Now all I got to do is mess with my my X, and then my my other guys will update. It's cool, right? Yeah, it's really cool. I want my amplitude. I want my amplitude to be higher than that. Let's do 4.5. Now look at what roughness does. That's a big one. This becomes a big deal in shading when you've got a super reflective surface. You pretty much want no roughness. You want smooth roughness, and then when you go all the way up, that's when all the light rays are getting scattered in all these crazy directions. That's because it's high roughness. But anyway, this is a visual way of thinking about it. Roughness. Let's bring that all the way down to 0. Offset. What is offset? It's just like, it's just moving. It's just translating. Okay. But look, what we want is actually Y. We want to move Y over time. So can anyone think of a variable we can use that changes over time? Huh? Bingo, you're getting all this, the dings today. $F, uppercase F. There's also $T, which is seconds instead of frames. Frames, now that's going like crazy fast. I put my real-time toggle on there. But we can slow it down. All we got to do is times it by 0.01. And now it's nice and slow. I got a 0.01 in there. Let's see your noise on your on this guy. What's it look like? Oh, put it into CD. You got it. You were right there. Just put the noise into CD. Yeah. Beautiful. Then take your frequency down. So scroll up a little bit. Somehow it's got lost. Is that all you have? You don't have frequency? So go back in there. Oh no, it's there. It's there. I think you just for some reason, yeah. Bring this guy down. Like open up the window more. There. I see that it was promoted. Again. Down here. Now you want that to be a lower number, like 0.15. And then you can make sure to link all your relative references. Good job. Good job, row 1. Good job, row 2. Getting there.
There, yeah.
Yeah, but look, there's nothing going on there. Gotta get something in there. See what the. Sure do. Got that, yeah. Good, and then go inside from it. Yeah. Gotta get this guy into CD, or else you won't see anything. All the way to CD. All good. Yep. Okay. Normals. Let's add some normals. There's many ways to add normals. I'm going to use a facet node. And post compute normals. Put your normal display on so you can see it. Now we're kind of at a large scale, so I'm going to teach you how to change your display settings. With your mouse in the scene view, hit D, go to guides, scale the normal. Now remember, I hit that on by clicking on this guy right here, normal. Hit D, scale your normal with your guides on there. We're actually going to come back to this in a second. You know what else I'm going to fix is I don't like my origin nomen. Let's fix that too. Under guides, turn off origin nomen. I like my corner nomen, bottom left, but I don't like my origin nomen. Okay, that's all in the display. You can always take that off and on. If you make your normals before you scatter your points will inherit those normals, because normals need faces to figure out where to point to. Tab scatter. However, one thing we didn't do. Go back into your density noise. And out of your AA flow noise, I want you to do a bind export. We need a custom exporting of an attribute. Call this density, because we need this for our scatter. And you'll see it. Hide all attributes, density. We now have density. Okay. Let's turn on the density attribute. Raise your hand if you need help though. Okay. But check this out. Look how that works. It's based on, I'm just going to keep playing. See, it's based on the density is based on the noise that we made. Sure. Sort of never. We went input connected and then take your noise and put that in there. And then let's go out. And then make sure you click on post compute normals. Now you have normals. Before you had pretend normals. Oh, that. Go inside. This is a gotcha. No, I'm saying not go inside, but you changed the wrong thing. Total normal mistake though. So name. So So one is the name of the attribute, the other is the name of the node. Oh
Okay.
my god.
Okay.
There's ways around that, but we won't get into that. Good over here? Yeah. Yeah. Cool. Cool, 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 cool. I'm sorry, it's loud. Yeah? Oh, go back here. Well, we'll see, dollar sign F. Now we can say, oh, I didn't even, yours should have been moving before because I didn't even put my dollar sign F in here. Do you have dollar sign F in your offset of your noise up here? I don't think you do. I'm in my noise of the density noise. Go to your offset and make sure you've got. Okay. Okay, well, then actually let's do, instead of one F, put two Fs. That way we get subframe information. Floating frame. Otherwise you're getting an integer actually. You're getting 1, 2, 3, 4, 5, 6. But if you do FF, that's floating frame. Again, global seed, dollar sign FF. Also, we don't want nice orderly placed points. Turn off relax iterations. We want total randomness and mayhem. We can also add another 0 here. Almost there, guys. Okay, we got our normals. They're all going straight down. We need to randomize not only P position, but now we need to randomize. Good time to save. File, save as snow. Underneath the scatter, we want another VOP. Point VOP. Okay, let's go inside. You okay? Okay. Tab, turbulent noise. P goes into P. Right click or middle click onto turb noise. Vex VOP options. Create input parameters. Let's just take that right to N. And that is not what we want at all. Let's make sure our turbulent noise is 3D noise and not 2D noise. Okay, so one thing we have to do, and this is a little confusing, is we have to add our noise back onto our normal. Tab add. I'm going to explain this in a second. Okay. So this is what I've got, you guys.
Input 2 is normal, right?
Yeah. Everybody got this? Let me see. Okay. Yeah.
Quick thing, with yours,
Yes.
it's almost flipped direction.
Okay. Yeah, facet. Post compute normals in your facet to make sure you've got your initial normals. Now, just a quick thing on why do we add noise back onto itself? It's easier to explain with P, and then it will infer with normals. So if I've got P that goes into noise, actually that's how we start. We start with P going into noise. What you end up with is just a crazy noise, like going from 0 to 1, or -1 to 1, or -0.5 to +0.5. It's just a noise field. But let's say I've got a circle. If you add the noise, so this is the original P, let's say. All the P's on this circle go into the noise function, and this is what you get, a crumpled noise, right? If you add these two together, what that equals this. Because you're adding the existing P to noise, and that's how you get something that resembles the original shape. If that makes any sense at all. Maybe. So same concept with N. We start with normals that are going up or down, you know, straight up or straight down. We get some noise, but it's a kind of a craziness. And what we want is just a little bit off of what we had. You know, it's just we don't want it to go every which way. We just want it to be a little bit off. That's why we add it, so that it kind of resembles the initial place we were at. Now, if you were to multiply it instead of add, you get like this, because then your zeros count for something. When you add, your zero doesn't matter, right? Something plus zero has no effect. So when you add, ones mean something and zeros don't. When you multiply, ones mean nothing and zeros mean something. So you really get different effects with multiply and add. But it's all fun. It's all fun stuff. Okay, let's go back out. Noisy normals is what we're calling this. Noisy normals. Instead of alligator, I want sparse convolution noise. And already I'm getting kind of more interesting effects there. Let's do a frequency of 4, so high frequency. And 4 all around, you know, do your relative referencing too. Higher amplitude of 3. Okay, so we're starting to get some going in the opposite direction, so we're going to have to kill those. So that's the last thing we're going to do. We're going to kill those guys. That's where multiply comes in. Or actually what we'll do is let's see. Okay, this is kind of fun. So here's a handy trick. Anyone know what the absolute means?
Anything that's a negative value becomes positive.
Say that again?
Anything that's a negative value becomes positive.
That's right. That's right. So anything, it just, absolute means we're only going to get positives no matter what you are. So anything that's negative becomes positive. That's right. But that means when I did that, remember, positive is going up. We want our rain and our snow to go down. So then we had to negate it. So basically absolute negate gets everything going down. So negate is obvious, right? It just flips it. I hope it's obvious. There's more controls we can do. Like I've seen that some are going kind of straight out to the side, but we'll see if that becomes a big problem and we'll fix it later. The way to fix it is we give bias to Y. So we'll do that later if it becomes a problem. Okay, lastly, I want you to also put this value in not only N, but V for velocity. So it needs to go out in both normal and velocity. Okay, ready to make our particles. Okay, go back into your terrain really quick and make sure you've got a null, and because we're gonna need this guy. Terrain out in your null, all uppercase. When you're ready, go back to your snow, tab, pop net, pop net. Go inside your pop net. Ooh, one last thing. Our noisy normals had some animation. Or maybe not. Okay, we're good. Okay. So we got our pop net. Let me make sure we've got velocity going. Yes. But they're all negative numbers. Oh no, that's fine. Sorry, 1 second. Okay, so first thing is we've got points, so we don't want the emission type to be scattered onto surfaces. We want them to be points. And now when we play, we have snow. We're done. Class is over. Just kidding. Okay. And that's what's neat is that we get the variability of the velocity, right? The direction, the patchwork. We don't really need that color. We can get rid of that color in a bit. But already, we didn't even do anything and already our sim looks pretty good, right? I'm gonna add another 0 to my playback because I want to see my snow. Reach Tommy. Let's get him wet. Okay, so yeah, it's going outward, which we may not like, but also I think there's just too many. Let's go to our scatter and reduce instead of 10,000, let's do 5,000. But we also need to match. We need to match the scatter with what's coming out. So source, emission type points. Use first context geometry. Actually, at this point, I just want to make sure everyone's where I am. So I'm just going to go around really quick. Make sure everyone's good. 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 Cool. Go first row. Excellent. Cool, man. You got some wind. So your display flag isn't on your comment. So good. Just in case. Oh no, you're good. Yeah, you're good. Cool. Okay. Okay, so mine are just kind of going too crazy, so maybe I'm going to take my amplitude down first. Yeah, I think I'll stick with that, with the lower amplitude on my noise. Okay. The other thing is I want let's check our activation here. PopNet. I don't want constant. I actually want impulse. I want I just want a lot of bursting to happen. So I'm turning off constant, but I want my impulse to match the exact number of points I have. This is where our relative reference comes back. I go to my scatter, I right click, copy parameter. I go inside my PopNet. I right click and I say paste relative reference. And now if I change my scatter, or vice versa, if I change this number, my scatter will change. If I change my scatter, this will change. They are now linked together. So per point, I've got a 1-to-1. See how more it like kind of defines it? Because I've matched the number of points. Let's add some gravity. Bring up, let's get some space there. Bring up your pop source a little bit. Tab force. Pop force. negative. So gravity traditionally is negative 9.8, but we get to play God here. We'll say negative 1.2. Negative 1.2. Could also get some wind by saying 0.25 in x. So it has a little bit of a slant. We can add another layer of noise here. See this noise down here? You know, you've got these vex expressions. You could start playing with that too. Orbit the origin. Let's see what that does. Whoa. Now you've got a galaxy. Okay, we're in outer space. We are now in outer space, you guys. Pretty cool. Huh? We're in a candy land. Randomized magnitude. That's kind of fun. I might keep that one. You can learn a lot by these little snippets that they give you. Okay, same with noise. There's vex expressions with noise as well. But let's do this. Amplitude, swirl size. Again, another name for frequency. This is probably because it's curl noise inside, but swirl size, 15. And curl noise on particles is quite nice. I'm going to turn off my vex expression just to see if I just want to see my curl noise better. Turn my amplitude up. There we go. Do you see that? How noisy it has become? Then it gets all nutso. So I'm taking the amplitude way down, but at least I know it's going to work. And then we're going to do the same thing for the offset in Y. $FF times negative 0.0002. So our noise is animated. Animated noise is really good. Might look different when we get close up, but and then it kind of breaks apart. I mean, you could spend a lot of time on this stuff. It's quite addictive. Let's add some drag. Tab, drag, pop drag. Got a lot less particles on my my teacher machine here. I'm going to take this down to 500. And again, if you change it here, the scatter changes. It's a bidirectional link when you're relative referencing from parameter to parameter. Cool. See that noise going through there? The drag is nice. And let's go back and see how Tommy's doing. Well, let's get a camera. No cam. New camera. Let's zoom. Space G. Zoom out. Well, the snow is just kind of going through the floor. We need to change that. Let me make sure everyone's good. So they're not flowing downward?
No. And I'm not sure if there's a hole.
Put your display flag here. No, turn it off. There's a comma in there. What you meant were for zeros. That's all. Good points. Yep, that looks good. Yeah, you got it. Do you want to keep going or?
No, I'll just watch.
You can watch it?
Yeah.
Okay. Oh, you just made it. Yeah, we just all have a little yeah. Cool. No, let's get, 5,000 is too much, let's do 500. You can just type that right into your impulse count.
Okay.
Yeah, everyone, let's get less particles. 500 is plenty. Okay, I want to change the way my points are displayed. D, geometry, display particles as points, display particles as disks. Now I can see them better. So that was pressing D, disks, okay. Let's also change, we don't want the colors to be like that, so let's go into our snow, go into our density, and let's break the connection going into CD, and now it's just should be white. but I don't see my discs. Oh, I do. Okay. Kind of like the black and white though, because then I could see, like, I don't know, maybe we go back.
Where was the setting in D? We're making the discs. Where was that in the D setting?
D, geometry, discs. Geometry, display particles as discs. Yeah. Does everyone have that one?
How do we make less snowflakes again? Decrease the level.
You can decrease in two ways, either the scatter or in your impulse count. Still too much. I'm putting 100. Okay, that's better. If you're just really quick color, what we can do, ramp from attribute density. Instead of black, you can change the color to something else. It's just a ramp from attribute density. Okay, let's turn our terrain into a collision object so that the snow sticks to the floor. Under drag, tab, pop collision, pop collision behavior, sorry, pop collision detect, tab, pop collision detect. Go into your detect. Find your terrain null. Okay. Find that null that you made, terrain out. Go to your behavior, response, stick. Stick. Let's see if that works. Actually turns red when it sticks. We can turn that functionality off. It says color hits right there, so you can just turn that off if you want, but now we know it's working. And hit is an attribute, of course, so you can use that all that stuff as a trigger. Oh, right. You could do it that way then.
Yeah, and it bounces, which is kind of cool, but
you've gotta add your collision. Right here, pop collision detect.
Yeah, that one would be good.
Let's go back to one and press play. Yeah, if anyone wants to do the orbiting around the origin, that's a fun one. It's under your force. Okay, so we're getting to the end, you guys. I thought it would never end. We are approaching the end. Yeah. Uh-huh. I don't know which one okay, but now it works. Yeah, well, German does that, right? But let's see, I don't even know if I've got 0.05. And I didn't even do it on here. 0.05.
Yeah, because I got this, I gave him the same value, and the snow wouldn't even make it to the floor.
Try 0.05 on yours.
Ray resistance?
Yeah.
We're dragging it unbiased, creating a little.
Because it really changes everything, that drive.
Make that zero. Go back to the meeting.
Yeah, but it's just like, I don't
Yeah,
know.
it's
It shouldn't
like-
be like that because ours aren't like that. So.
Yeah, why don't you delete it and rename it pop track? Maybe that'll fix it.
Yeah.
It's just pop track. Yeah. Sometimes that just fixes it, just doing that for.
Oh, okay. Some of these computers, like this as well, has a really unexpected result. It's different than everyone else, and I think yours is like that too.
Yeah, just bypass it.
Yeah. There's a ghost in these two machines. Okay, so we only have 20 minutes left, you guys. Oh my gosh. I'm just gonna teach you how to render. We'll do that for the last part of this class, so just bear with me. I'm just gonna have a tiny bathroom break and I'll be right back.
Anyone have any questions? What's the meaning of like, 42? Got it.
I thought it was happy, but close enough.
That was 24.
Huh?
That was 24.
That's how many frames per second it's supposed to be.
Okay, guys. Okay, guys, so how do we render this?
Yes. Slow down.
Okay, I'm gonna redo my snow, replay it. I'm gonna replay it. Okay. At this point, I'm going to press Command and get an environment light. Command, hold Command and press environment light. Did I get one? No. Or maybe I can't see it. Which, maybe it's this. Come on. Okay, it just doesn't like my pen. Okay, same deal with my environment light. Going to my render view and I'm going to hit render. Wow, look at the huge size of my particles. Someone laughing at my frame?
Those are some big golf balls.
Those are big golf balls for sure. Okay, quickly, let's go into our snow, go inside, attribute, randomize, tab, attribute, God. What is going on here? It won't wait for me to do this. Okay. Ah. P scale. 0.01 to 0.1. Render it again. Certainly did not work. It's funny. To go, I gotta simulate it maybe again. Okay, let's pretend we like this. Now, let's go back to our light, render light geometry, enable sky environment, color the light if you wish. Up the light intensity. This doesn't look like a snowy environment, but you know, we're from LA, so. Huh?
What do we know?
What do we know? Not much about snow, that's for sure. Okay. once we hit render, in the render view, we get something, new context, out. This is the ROP context. So what have we learned today? SOPs, DOPs, VOPs, and now ROPs. Everything with an op sounding. I learned a lot of ops today. We are now in ROPs. This is a mantra ROP. You can have a million of these, have different render settings, merge them all together, get all these cool different passes. I'll talk more about this next week or in 2 weeks, but like for now we're just gonna like do the basic stuff. What I really want right now is motion blur. Let's allow motion blur to happen. Okay, but we only got like a little tiny bit. That's because we got to do something else for motion blur. I'm gonna go to the snow object and turn on geometry velocity blur under the sampling tab, under the render tab. Now there's other ways that we can make it look better, but it kind of looks like poop right now, but you know. Snow. I might be going a little fast, but basically I was just in the material palette. I copied a principal shader. Let's see if there's one that already kind of what we want. Principal shader. Let's go to OBJ, snow. In the material for snow, go to your matte and get that principal shader. This is one way. Now our snow has shadows. I can jump to my shader. Let's make sure our shader is white. It's picking up the pink. It's picking up the pink. We don't want any reflection. I'm going to take that all down. But let's see if emission gives us anything. Emission color, I'm going to make white. So now I'm kind of faking it a little bit. Emission, I'll make it a little bit of a gray. So a little bit of my pink comes through, and now I'm faking my snow. That looks a little bit better. Go back out to the out context. That's ROPs out. And then all we do to render a sequence, render frame range at the top here, it automatically picks up your timeline. So if you don't want it that much, you can always change your timeline. Actually, this picks up your global timeline. So just delete these channels and just put in, and I've got the rainbow of death. Let's say 200. Make sure you save. Images. These are going to save EXRs. If you want, you can just type PNG. Save you time. PNGs are faster. EXRs are great for like final renders. And then, where's this going to go? $hip. It's going to go where you saved your file. We'll talk about how to set that later so it doesn't move around. $hip is where you saved your file. It's going to make a folder called render. It's going to name the file, the name of your file, dot the name of this node dot $f, which we know is frame, and 4 is padding, 4 zeros, dot png. I hit render to disk, and that's it. So that's it, you guys. We did it. Day 1. Did you learn something? Yes. Pretty quick rendering.
Do EXRs have compression forms, or is that just BGOs?
Ooh, I don't think EXRs are compressed.
Okay, so they don't have
I'm
compression.
gonna interrupt that. No, I don't think so. PNGs are though. They're compressed.
Yeah, because a lot of the time I render, my EXRs come out like 5 to 10 gigs per one. It's just like, yeah, they get kind of large.
Yeah. I can say view mantra to get up my mplay. And let's see, did it render a frame? Oh, it's gonna render one now. So this is a real frame. The render view is like pretty good approximation,
Did you,
but there's sometimes differences.
did you do any passes or just the regular?
No passes.
Okay.
File, open single file. Hip. Desktop. Render. It did 1 frame. That's awesome. No snow. I don't know where this outline is coming from. Yeah. Any questions, you guys, about anything we learned today? Nothing?
Okay, great.
Ready for bed?